Hello, my dear students. Welcome back to our science class. Before we proceed to our new lesson, let's do pre-assessment. Complete the sentences using the words in the box. You're going to write your answer in the chat box. Let's begin. While drinking a cold glass of lemonade on a hot summer day, a person feels water on the outside of the glass. Did the water on the outside of the glass most likely come from the lemonade, the ice, the glass surface, or the air? We will find out the answer. Today, we're going to learn about Lesson 3.6, Gas to Liquid. On your student book, it is on page number 50 to 51. The learning objectives of this lesson: first, to analyze that condensation is the opposite of evaporation. Second, to investigate how gas turns into liquid when it's being cooled. Before we proceed further to our lesson, let us read the definition of the following keywords so that you will be able to understand more the concept of this lesson. The keywords are vapor, cools, and condensation. When we say vapor, it is a substance in a gaseous state that is often visible in the air. When we say cools, if something cools, it becomes a lower temperature. Third, condensation. It is a coating of tiny drops of water formed on a surface by steam or vapor. You need to read and practice these keywords so that you will be able to understand more the lesson. Now, let's find out where the water outside of this lemonade glass comes from. For letter A, it says that there's a lot of water in the lemonade. I bet that's where the water is coming from. Letter B says, I think the water comes from the ice. Ice is pure water, just in solid form. Letter C says, I think the water comes from the surface of the glass. I mean, it's right there on the surface. And letter D says, I think the water comes from the air. What will be the correct answer? Letter D. The water that appears on the outside of the glass is from the air. Invisible water vapor in the air condenses into liquid water when it comes in contact with the cold surface of the glass. What we call the process of condensation. Condensation is the change of states from a gas to liquid. Water vapor and steam will turn back into water when they are being cooled.
Minimize it in your home.
Condensation
appears when warm, moist air comes into contact with cooler surfaces, like your window glass on a cold winter day. That's true with even the best performing windows. Although condensation is most common during the winter, it can occur whenever water vapor in warm air contacts a colder surface. That's why your iced tea glass sweats during the summer. The glass is cold, and condensation forms when warmer, moist air comes into contact with it. Everyday living generates a surprising amount of indoor moisture. Cooking 3 meals a day adds 4 or 5 pints of water into the air. Each shower is another half pint. Every activity that uses water adds moisture. Regardless of its cause, the moisture source doesn't have to be where the condensation occurs. Vapor pressure can actually force moisture through plaster, wood, brick, and cement.
Now you know already what is condensation. Remember, gas is one of the 3 states of matter. Liquids can turn to gases and gases can change back to liquids. These are reversible changes. Gases can change back to liquids when cooled. When the heat energy decreases, the gas particles lose energy, slow down, and convert to particles of liquid. This is called condensing. It happens at any temperature between the melting point and the boiling point of the material, but is greater at the lower temperatures. There are many examples where condensation and evaporation are useful. What are the examples of condensation? Dew forms in the morning on leaves and grass because warmer air deposits water molecules on the cool leaves. Another, observe a Coke can when it's taken out of a fridge. Drops of water can be seen on the outside of the can. Water vapor in the air touches the cold surface of the can and changes to water. Another example, the mirror in the bathroom during a shower becomes foggy because warmer water vapor in the air hits cooler surface of the mirror. You know already what is all about condensation and what are the different examples of this. Remember, water vapor and steam will turn back into the water when they are cool, so this process is called condensation. For your first assessment, let's do in quizzes. The game code will be provided during the online class and the time limit for this is only 5 minutes. Now, let's proceed to our second objective, wherein you're going to investigate how the gas turns
For this
into a
experiment,
liquid
you will
when
need
they are being
hot water,
cooled.
2 cups,
Let's
and some
watch
ice
this
cubes.
experiment video.
First, boil a kettle full of water. Fill 2/3 of 1 cup with the hot water you just boiled. Flip the second cup, placing it upside down on the first cup. Balance an ice cube on top of the flipped cup. It is very slippery, so make sure it does not fall off. As the ice cube melts, condensation will begin to form inside the second cup. If you look very closely, you can see the smaller water droplets form together, making bigger water droplets. Clouds are made of these same water droplets, but in the sky. If you wait long enough, a big water droplet will form underneath the ice cube. This is because the ice cube, like the atmosphere, is cold, and the water underneath it, like the surface of the Earth, is warm. This process is known as condensation.
Now, you learn already what is all about condensation, the different examples of condensation, and how the condensation happens. For your second assessment, let's do in Portal. Enter the registered number and your password, and you will see the worksheet that you're going to do. The time limit for this activity is only 5 minutes. January, we will do in Mentimeter. The link will be provided during the online class. The time limit is only 2 minutes. today, my dear students. For additional homework, just download the homework task PDF in the school portal and do each activity. Have a nice day and take care, everyone.